Today, ladies and gentlemen, we are going to have our second booth talk here at SEI at COP16. And our speaker today is Dr. Tiit Kallaste from the Tallinn office of SEI, who will be speaking about biogas and the potential of biogas to become a strong source of green fuel. Tiit, the floor is yours.
Thank you. So, in Estonia we have got a wave of biogas studies, and we started with a project which was launched by the Nordic Energy Research Fund, and it was called biohydrogen, and it was based on the plant's generation of hydrogen. But you know, we studied in the chemical laboratory. One of our colleagues, Dr. Anne, is working in the chemical laboratory, and after many years of research, we found out that the yield of hydrogen is relatively small. So you can get hydrogen out of plants as a result of photosynthesis, but the yield is so little, and then you compare the energy what you put into the process and what you get out in the form of hydrogen, and that's relatively low. So, but that's the project which is coordinated by Uppsala University in Sweden, and we have been partners there from the side of Baltic states. The side of Estonia we have Latvian University of Technology, our partner, and we have people from Norway, from Iceland, from Aukeri, and we have people from Tampere and Jyväskylä from Finland, and from Linköping and Uppsala, Sweden, also Technical University in Denmark. So there are many ways to get hydrogen out of the plants, but we decided that, okay, as the yield is so little, we better think for methane. And methane seems to be very good to work out based on the wastewater treatment plant sludges, wastewater, and in fact it works quite well. So Dr. Menert in her laboratory made many approaches to get the higher yield of methane, and she succeeded. So now we have got to the next step in our studies, and we've got one Interreg 4A project which is called Waste for Transport Fuel. As we know, you can use biowaste to produce methane, and methane is in fact it's biogas. So if you clean up the biogas from the process and concentrate the biogas, you can get even the same percentage of methane content, which is around 96%. It's like natural gas you use in the cars and buses. And again, Swedish experience shows that biowaste from households could be effectively used for the fueling of city buses.
Is methane already being used to fuel buses anywhere?
Absolutely.
Yes.
We were recently in Uppsala, and we saw with our own eyes that 1/3 of the bus fleet in Uppsala is fueled by biogas. It's great. You get a huge reactor, you treat the biowaste from households there for 3 days, you heat up the waste up till 70 degrees to get rid of every bacteria there, and then further treatment for the rest 3 days, and you get out methane, which is still a little bit low concentration, but still. You then purify it, you concentrate it, and you get it into the tanks where they are transported, biogas is transported to the bus company. And buses around just are feeded in, are fueled all over the night. They came in the evening, they have still rest in the balloons, which are on the top of the bus, and they are fueled again. Let's see, 200 atmosphere, I guess. And in the morning they start running again, so it's very, very nice. So we now got a project which is called Waste for Transport Fuel. We have got here a flyer, Waste for Fuel. And the aim of this project is that we will make inventory in 2 countries, in 4 municipalities in Finland, and 2 municipalities in Estonia. So Finnish municipalities are Helsinki, Kotka, Salo, and Helsinki, Salo, Kotka, and
I could imagine that biomethane has a lot of advantages compared to biogas, because biogas need to be burned where it is produced in order to produce energy.
I come to that. So there is 3 options to use bio-waste-based methane. It is, you can burn it straightforwardly, you get the heat, you heat up the houses or whatsoever, but it's relatively inefficient use of biogas. The second option, you deal with cogeneration of heat and power through CHP, and it's much more efficient. And the third option is just to use it straightforwardly in the engines, like in transportation. You get the highest efficiency of using biogas. So we are aimed now to this third option. Nevertheless, we have several CHP plants in Estonia already. In 2001 we started a project in Tallinn. Tallinn is capital city in Estonia, in Tallinn landfill. And we started with the first CHP unit which produces electricity and heat. And heat is used to heat up around 1,000 flats nearby, not far away from this landfill site. And electricity is fed into the grid, and we use feed-in tariff for that, so it's economically very feasible. And in 2004, another unit, also 835 kilowatts of electrical power and 1.1 megawatts of heat capacity was launched. So we work on full load with this Tallinn closed landfill site. And if we think over that, many countries around already use the biowaste from households, from canteens, restaurants, kindergartens. So that's our future, to use methane gas most efficiently.
How do the costs compare to that of fossil fuels?
This is the last phase of our project, so we will come to that. But already in advance we can say that there are a lot of advantages. You don't have dumping site any longer. You just put all the biowaste to the bioreactor and you get methane gas out. And then once you have dumping site, you have very bad smelling there around, you have birds coming to this dumping site, so you hit many targets at the same time.
The costs are higher compared to fossil fuels, but I think among all renewables you have the advantage that biomethane or biogas can be used for baseload. This is the disadvantage
Absolutely.
that others have, like wind or photovoltaic.
And as EU countries have their targets to go over to renewable energy, we are towards the same target. So nevertheless, we have wind, we have small hydro, we have biomass. Now under this biomass we can split biogas, which is very important for us. And not to speak about the burning of bio-waste. There will be struggle. Who will get more waste from big cities? And that's a trend nowadays. Who will get more waste, because you get it free from the people around, from the restaurant, kindergartens, etc., from hospitals. But to use it to generate biogas, it's my fingertips tell me that it's the most economically efficient way of using waste, not to burn them. Because once you burn, you get again emissions to atmosphere, you get something to water, something to the landfill, and thereafter you have to transfer this energy. But using in the transport, in the engines of buses, you get the energy here and now. Nothing is lost in principle.
What surprises me is that you are saying the efficiency for mobile applications is higher than from CHP. I doubt, because usually you have the highest efficiency for CHP applications.
Yeah, I didn't hear you.
Yeah, you said that not combined heat and power, CHP, would create the highest efficiency, but they use the fuel for buses. And I cannot believe it, because in a bus you have a standard burning process, and
but you have to consider that you will lose energy. You transfer the energy and you get losses anyhow.
Yeah, but the advantage, if you have once reached biomethane quality, and you said it's more or less equal to natural gas, you can feed it into the grid and consume it everywhere that you want to have.
I come to that. So our aim, the final aim, is to fix the network of gas stations, biogas stations all over the country. Now we have pilot counties, 2 counties in North Estonia and 4 counties in Finland. So we make a study how feasible it is compared to the rest of the fuels which could be used for transportation. And the final aim is just to put the grid of biogas all over the country, and of course in the places where you can't feed into the say bus company or etc., you feed it into the natural gas network. In Germany, if my memory is correct, there are more than 50,000 engines working, or say cars working on biogas already nowadays. So we would like to come closer with that. And if you think about the figures, then one cubic meter of garbage, biowaste, it's around 220-250 kilograms. You take 1 ton and you get 5 cubic meters of biogas. 5 cubic meters of biogas. Then 1 cubic meter gives you around 5 kilowatt hours of energy. So you get from 1 ton, which gives you 5 cubic meter of biogas, you get like 0.75 megawatt hours, which is rather significant amount of energy. We know that fossil-based energy nowadays costs a lot, but now you hit 2 targets at the same time.
Why has it been so difficult why hasn't this taken off in a bigger way in more places already? What are the challenges that get in the way?
Yeah, maybe that's quite new for many countries around. So, like in Finland, you don't have any bigger biogas fueling station. Not to speak about Estonia, we are not yet there. But probably that's answers in the technical progress, and of course the stimulation. What are the how to say economical tell me the word. So I can't say it in English. So you should have some candy for that.
Incentives.
Incentives. Yes, right. Thank you. So we must have incentives, and the incentives are in this case many-sided. Environmental incentives, jobs, and then economic efficiency. And I do hope that next year we come to the energy efficiency analysis in our project, and then we can tell that, look, waste for fuel, that's something real for small countries like Estonia and Finland.
Great.
Thank you.
Thank you very much.
Thank you.